All right, so I'm gonna do a quick video on some of the details of my Holley Sniper fuel injection, the installation, and kind of overall of what it's taken to make this thing work. So I'm trying to do this quick, so I'm not gonna do any like real editing, so hopefully this works out. So here's some photos off of my tablet. So first off, here's a gasket for the Holley Sniper sitting on top of the Samurai intake. So you can see, you know, the larger secondary butterfly opening is pretty close to the right size, but you know, the primary is way too small. So on a Samurai, you know, it's a progressive 2-barrel. Part throttle runs on this guy, and then, I don't know what it is, half throttle on up or whatever. This one opens up. On the Holley Sniper, it's a synchronous carburetor, or a synchronous setup. So it's got 2 butterflies, but it's not a progressive linkage. This shaft goes through both throttle blades or butterflies, so they open together. My goal was to not have any adapters. I know some other people have built them with some adapters. I chose not to because adapters require multiple gaskets and that's just more places to leak and whatever. So first off, I opened these up, combination of, you know, a die grinder and hole saw and just kind of whatever it took. So I just scribed out the opening size I needed, and then went to town. And if you can see, getting in there close, I also tried to blend all the edges really nice, give everything a nice smooth radius, just to help airflow. Not sure if it really helped. These intake manifolds are pretty restrictive with these tiny runners. I think there's a lot of restriction in here that hurts power, but this was basically just to get this thing together. If you've seen some of my other videos, I'm working on a new manifold. Let me go back. So you can see the holes are very close. And it may be possible to leave the holes in the manifold and to file the holes. I don't know, it'd be really close. I didn't want to modify this because you know, it's quite a bit of money. When I bought mine, it was like $1,100. I'm not sure what they are today. I bought mine about 2 years ago. So I wanted to leave the actual unit alone. Leave it alone. It would be really tight. You may be able to file the holes in this to get it to work, but I just didn't want to risk it. So you can see in this picture, I welded up the original stud holes. I just used a MIG welder, aluminum spool gun. It worked okay. You know, these things are always so nasty. It took a lot of cleaning to get it good enough to weld. And then getting the wire all the way down in the base of the hole to fill the whole thing. Like, it wasn't ideal, but you know, these aren't under a ton of stress, so it worked out. I luckily have a small milling machine, so I was able to surface this nice and flat, take all the welds down. But this is kind of the finished product. I don't have any pictures of drilling and tapping it, but you know, you can kind of get a pretty good idea what I went through. And then basically I used the gasket, scribed the circles, and carefully center punched and drilled and tapped the new stud holes. And then I like to use these studs. It's kind of like a really long set screw, or like a grub screw. It's got a little Allen head on the end of it, which makes it nice to install it, and also hold on to it when you're cracking the nuts loose. You can hold on to them so they don't back the whole thing out, because sometimes there's not room for the whole stud to come out. It'll bottom out. I think it's the other side, but anyway. These are cool. I like them. You can get them at like Ace Hardwares and stuff like that. So that was the main part of just getting the thing mounted up. Previously, this had a Weber carburetor on it, and so I sacrificed this little, kind of like a quarter of a pulley, and it has the little barrel connection for the throttle cable. So I cut that off of my Weber and welded a little piece of metal to it, and then it bolts to the linkage setup on here. Because I wanted to reuse original throttle cables. I want to keep it easy to do maintenance on this down the road. So that's the throttle cable. This hat I had picked up used forever ago. This was actually on my Weber. This was built, it's made by K&N, and it's for a Weber 3236. So I had to build a new bottom plate because this has a small, and I don't remember the size. It's like a roughly 2.5 inch neck on the top of it. So I made an adapter because this is like a 5 1/8 or whatever kind of a standard V8 size is. And then for, you know, your air filter, there's a million ways to go. Mine goes through the firewall because my air filter sits inside the car. Mostly just for dust. You know, going King of the Hammers and desert racing events are so dusty. Having it in here helps quite a bit, keeping it cleaner. But one thing I added that's not part of, so I ordered a master kit for this thing, and it comes with like nearly everything you need. It comes with fuel line, the fuel pump, you know, all the wiring obviously, and all of the stuff. But one thing that they don't include, which I really think they should, is a test port for the pressure. So this is like a Schrader valve, like would be on a tire. You know, most cars have these, you know, OEM. So with my clearances and whatever, I had to do some different fittings, and these are just hydraulic fittings. If you're not aware, you know, most like the race car and fancy stuff use AN fittings. GIC, which is what common in hydraulics, are totally interchangeable and way cheaper, and generally made of steel, so they're tougher. So everywhere that I need fittings like that, I generally go with GIC. So anyway, there's my test port. Because it's pretty important, and early snipers had a lot of problems with fuel pressure, and so you need a way of testing it. The pressure regulator is a kind of a diaphragm set up inside of here. This is the return line that goes back to the tank. So the fuel comes in this side, and this is like a little mini fuel rail because the two injectors are here. So this is the regulator. Like I said, early versions, a lot of people had trouble with these not giving the correct pressure. Mine's been fine. I haven't had any problems with mine. It's supposed to be like, you know, basically 60 PSI. I think the range is like 58 to 62 or something, but you know, all that information's in the instructions. A lot of people, I've heard talk of needing to replace these injectors with smaller ones. I haven't had any problems with it. I've had this engine professionally tuned twice, and I've asked both guys, like, are the injectors fine? And both of them told me that the duty cycle that they're running is perfectly within a good safe window. So I haven't touched them. I did make my own little throttle cable bracket. I just used the top two thermostat housing bolts. And yeah, basically the cable's stock besides that. What else for mounting? I think that's basically it, getting it onto the vehicle. So when I first set it up, you know, so they come with this little 3-inch screen or whatever, little touch screen. And when you first get the system, there's a setup wizard. And you basically go through and you tell it like your displacement, and you got to remember that's in cubic inches for this. Displacement, number of cylinders, they ask you, like, there's like 3 kind of categories for the type of cam, you know, just some pretty basic information. And then you can do a self-learning, they call it. And honestly, the drivability and kind of low RPM, after 50, 60 miles or something, it honestly ran really good. The one place where it never did really seem to correct itself was wide open throttle. And I don't know if I just never gave it enough time or what, but at that point, I was getting pretty close to a race, and so I wanted to make sure it ran correctly, so I had it tuned professionally on a dyno, and if you go that route, be prepared to spend between $500 and $1,000. But the nice thing is, if you do the self-learning, drive it for a while, get it as close as you can, you know, let the software figure it itself out as much as possible, then the dyno guy is going to have to spend less time and ultimately should cost you less money. So that's what I did, and it worked pretty well. The first tuner, I wasn't super happy with. It ran good here where I live. I'm pretty close to sea level, but there's so many options in the tuning. He had limited the input of the O2 sensor, which makes sense. So it basically limited how much the computer will listen to the O2 sensor in case a sensor failed, then it really couldn't throw it super off. But the downside of that was it was tuned at, you know, approximately sea level, and my race was at like 4,000 feet. And so it was just not happy. It was running rich, and it just couldn't correct itself enough. And so that's something that's important if it gets tuned to talk to the tuner about. And then I've learned, I had one sensor go bad. I keep a handful of the basic sensors in my tools with me. An oxygen sensor and a coolant temperature sensor, which I believe is this guy. Yeah. So it's the coolant sensor that comes with the kit. So you got to, I believe I had to tap this hole slightly larger. National pipe threads. And then it came with an adapter and whatever. So I keep an extra one of these. Because again, the snipers get kind of a bad rap over some of their early versions that were released. Mine is, you know, several years later, and you know, it's filthy. Anyway, I don't do the best job washing this poor thing, but things that are really important are paying attention to your wiring. If it says go straight to the battery, go straight to the battery. There are so many places in a car that you can pick up interference, you know, electromagnetic interference. And so, you know, when you run the wiring, you want to try to stay away from the coil and your distributor as much as possible, even your alternator. You want to try to keep that stuff away from anything that makes power, or, you know, like your coil is basically takes 12 volts and ramps it up to 50,000 or whatever. So that makes a lot of VMF. Good clean connections on your battery, really important. You know, fuel pressure is really important. And, you know, then all the other normal stuff, vacuum leaks and whatever. But, you know, overall, I'd say that I've been extremely happy with this thing. And obviously the good benefits of fuel injection are it doesn't care about, you know, what angle the car is sitting, if you're climbing over rocks and uphill or downhill, you know, even upside down, this thing doesn't care, it just keeps running. And a side benefit I never even thought of is it's got like an automatic idle control. So it's got a IAC valve, which is basically, I don't know exactly where it's located in this thing, but it's a little path that basically bypasses the throttle blades to let some air through to control your idle. And when you get in the rocks and you're creeping along at an idle and you know, hit an obstacle or a steeper spot or whatever, and the engine wants to bog down, the computer will ramp the idle up to maintain it, and it actually makes this thing pretty hard to stall in the rocks. And on that little touch screen, there's a lot of values you can play with: the speed that it responds, how much it can respond, all that kind of stuff. And that takes a little bit of time just playing with it, but it works pretty good. Trying to think what else I should cover. Oh, ignition. So to do this by itself, it doesn't require anything different with the ignition. So I ran mine with the stock ignition for a while, and then I was having issues with my mechanical advance. It was just not consistent. I'd had my distributor modified and I just wasn't happy with it. So I went ahead and did the full Hyperspark ignition system as well. So you can see there's the coil. It's kind of hidden away. I have my cowl unbolted. Oh, I'm losing my control box. It's similar to like an MSD box. It kind of mounts on top of my glove box. Again, trying to keep it away from anything that makes electromagnetic interference. And it also, I guess, maybe can create some itself. So the actual computer for the unit is inside what looks like the float bowl. This is actually where the computer's housed in these Holley Snipers, which is cool because it makes it self-contained, basically. I think basic setup, there's only like 4 or 5 wires you got to hook up. There's like positive and negative to the battery. There's one that's going to go to an ignition on source. And then the rest just plug in, like your sensors, oxygen sensor, stuff like that. It's actually wiring, it's super easy. That's another important thing. I have a O2 sensor sitting right there, and I have like a Thorley tri-Y header. I first started using it with the sensor right there, and it had a real hard time. It ran terrible. So that sensor is actually just plugging a hole. That's a sensor that went bad, and so I just use that as a plug. The actual sensor is down below, so that there's 2 pipes right here, and then they go down, and then they merge to one. And then my oxygen sensor is probably 8 inches past that. So you want to make sure your sensor is in past the collector, so it's in just one pipe, so all 4 cylinders are feeding into it. That's real important on this. You know, performance-wise, I would say it's probably capable of more performance than say a Weber or a 3K or whatever, or a stock carburetor. I don't know. I never ran mine on a dyno before, but it's definitely got more CFM capacity than any of those other carburetors. And I think the limiting factor is the intake manifold, and you know, just flow through the head on this. Fuel pump is pretty important. It needs to be, if possible, below the bottom of the fuel tank. You know, it's just a frame rail mounted pump. There's really nothing to show there, but trying to think what else. I think that's about it. And again, like if there's any questions, well, I guess I didn't get into the ignition. So this thing slid right in the way that's covering it all up. So anyway, the ignition, there's a box that's similar to like an MSD style box, but it's just Holley's version. The coil, and then what that does, and there's some modifications you have to do to the distributor. But what that does is that all that plugs into the computer here and lets this computer control your timing, which is pretty beneficial. It gives you a better idle, and in my case, actually gave me more high RPM performance because for whatever reason, my engine likes about 35 degrees of timing through the mid-range, but at wide open, high RPMs, it made the most power at 32 degrees. And so I don't know if that's something you can do with mechanical advance in a distributor. I don't know at even higher RPM if you can take timing away. Maybe it's possible. I'm no expert in that, but so inside the distributor, there is a pickup. So like under the rotor, there's kind of a circular deal with 4 little skinny nubs sticking out. And as those pass by a pickup, that's what signals that, hey, it's time to fire. So that stays in place, and then the pickup itself stays in place. And next to the pickup in the base of the distributor is some sort of little module. That needs to be taken out. And so there was 2 wires between the two. I cut the wires and then extended them. And so those 2 wires just come out of the distributor and tie into the rest of the system. And then there's some, they call it phasing the distributor. There's some stuff you got to do to get all the timing right. And it's kind of a pain, but I could explain it if someone needs details on that. It'd be easier to walk somebody through it on the phone or whatever. But basically, you've got to make sure that as the timing changes, the spark is always happening within the little contact on the end of the rotor. Because if the base plate of the distributor, the base plate inside rotates, and actually had to tack weld. The base plate sits on a bearing so that the vacuum advance can rotate the base plate. So I tack welded the bearing together, and then there's some little clamp screws inside so you can turn it and lock it and it'll stay there. That needs to be done. It needs to be stationary. And then there needs to be so many degrees of difference between when you're centered on your number 1, let's say, deal in the distributor cap, and when the pickup fires. And it just takes some messing around, but it's not hard. And luckily the pickup inside this distributor outputs the same voltage and stuff as like an MSD distributor would. So amazingly, all this stuff is totally compatible with each other. I should have been more prepared. In my timing light kit, I have a distributor cap. That I drilled a big hole in it. So when you're setting all this stuff up with getting the phasing right, you can actually hook up your timing light, and instead of shining it on the front pulley of the motor, you shine it through this hole, and you can watch the end of the rotor and make sure throughout the timing range that the spark is always happening within that kind of banana-shaped thing on the end of the rotor. And then there's some other things I've done that have helped. This is like a positive piston stop. Don't trust your front cover to be totally accurate, because they're not, especially if you have an aftermarket one. I found that the marker, which is really hard to see, but the little marker down there, right down there, I've kind of got silver Sharpie marks on the, I found that guy's off like, I think it was like 2.5 degrees by putting the solid stopper in. You put it number 1, and then I would get it to, I think, about 10, and I would slowly turn this guy in with a screwdriver until you could feel it just touch the piston. And then you rotate the engine the other way, and then you kind of just whittle this down, and you're trying to home in on 0 a little. You can't be right on 0, but you need to be a little bit this way. Then as you rotate around, a couple degrees off this way, and it should be equal. Let's say you're 3 degrees. You hit 3 degrees before, and then you come around the other way and you hit 3 degrees before. It should be equal. Well, it wasn't. On the 0 mark, I was, it wasn't equal between the stops. So then I learned that this guy's not accurate. But the cool thing is, once you get, the phasing set up and, blah, 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 you never have to touch that again for doing the timing. It's all done in the software, and has basically infinite adjustment possibilities. So that's my setup. Again, I've had this, I think, about 2 years now, and it's never left me stranded. It's been super reliable. The thing cold starts like a brand new car. It's really been pretty great. I mean, I can show you. I haven't moved this car in at least a week. I mean, you can see it's cold. Let's see if this thing boots up. First starts up, it ramps the idle up a little bit for a second, and then comes down, and it just idles nice. Yeah, and this thing's got a pretty big cam in it. It's got a little bit of a lope to it from the cam, but yeah, you can just take off and drive. My old Weber was definitely not like that. It took a lot of time warming up and learning how to give the right amount of throttle to keep it happy. But so that's that. Like I said, if you got any questions, feel free to reach out. I've sent my file to some people. I mean, that's not always the greatest idea, but if you did this setup and you were lost, I'd be happy to send my file to you, and that would probably get you in the ballpark. Depending on the cam makes a pretty big difference on the tune with these, because it relies pretty heavily on manifold pressure, and so the cam can really change that quite a bit. But if you happen to have a 272, I have a cam from Low Range Off-Road. It's the 272 cam. They were actually made, at least when I bought mine, by a place called Delta Cam, in I believe Tacoma, Washington. If you happen to have that combination, it'd probably work great. And just so people can kind of get a rough idea, so it's got dished pistons still. The 272 cam, the head's been pretty heavily milled. This head was in bad shape. And to get it had already been milled. This engine started as like 3 different engines, a whole bunch of different stuff. But this was the best head I had, and to get it straight and parallel and right, it's got a total of 27 thousandths off of it now. So that took the 8.6 compression with the dish pistons up to 9.35. And then it's got a little bit of like valve deshrouding, and I don't know exactly what he did for like the valve angles on the cutting the valves and all that. I have no idea. Thorley tri-Y header, which honestly I don't like. I had a pace setter 4-into-1 header before, and I feel like it worked much better. But I got a good deal on this one used, and I ended up selling the other header. I wish I would have kept it. When I did this manifold, doing the modifications, I went through as much as I could and just cleaned up all the ports. What that's worth, who knows? What else is done to this? It does have an adjustable cam sprocket. Due to being shaved so much, that brings your two pulleys closer together, and that will change the timing of the cam. So when the engine builder put this together for me, you know, he was a high-end race car engine builder, and so he was very particular on how everything was set up. And so he made me buy this adjustable pulley, and he got it all dialed in so the cam specs were correct. And so this combination with the two different tuners, I have learned that dynos vary, and who knows what's what. I don't know the brand of the first dyno, but it put 68 horsepower to the wheels, and that's through you know, Samurai tranny, a 489 transfer case, and 512 axle gears on 33s. You know, basically just as it sits, it put down 68 horsepower. And then the second one was a dyno jet, and the guy warned me that it always reads low, and so it put down 52 horsepower on that dyno. But you know, he's had that dyno a long time and has used other dynos with whatever. So his best estimates at the crank, this thing makes 100 horsepower. That's kind of what both guys figured with the drivetrain losses. So, you know, it's still slow, but it's fun. You know, it's heavy for a Samurai. It's about 2,700 pounds right now. But it's geared low, and so it feels fun. Currently, I've got a stock transfer case in it for the sand dunes and the rallycross racing I've been doing. And so I run it at low range, and it just makes all the gear ratios work pretty good. All right, so that's it. Again, if you got any questions or concerns or, you know, tips even, we could share with other people. Feel free to share and comment. I do plan on doing a turbo with this and doing a blow-through setup with this guy, which the tuners assured me is totally possible and which should work just fine. So that's going to happen sometime this winter. And I can show. So I've got the manifold tacked together. It's got to be finish welded. That's a VW KO3 knockoff turbo. This is the other manifold I built. And this is a 1.6 8-valve head. They have larger exhaust valves than a 1.3, and also the diameter of the ports on both sides are bigger than a 1.3. There seems to be a lot of conflicting information on the internet about the combustion chamber sizes. As far as I can measure, they're the same. So the compression ratio doesn't really change. But I will edit this if that turns out to be different. But so that's my this is my winter project. I've got one more trip planned before this thing's going to sit over the winter. So that's my I'm looking forward to getting that on there. I'm hoping to make like 150 crank. I'm kind of torn what I'm going to do. This motor's only got 5,000 or 6,000 miles on it, but I might just build a whole other bottom end to put that head on. If I can afford it, I'd like to get some good H-beam rods and make it pretty solid, but we'll see what happens. All right, so that's it. Thanks for watching.